If you have a special pen, special highlighter, something, 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 you might want to highlight number 10. Anyway, number 10, you were supposed to use a double angle formula, and then you were supposed to factor. Set factors equal to 0, and then unit circle. What did I say you're allowed to use tomorrow? You're allowed to use your calculator. But think, what if this is a multiple choice question? Is it going to have decimals in it? No. So you're going to have to do a little finagling if you get a decimal answer to try to figure it out, right? Now, decimal answer, how could you use your calculator to not have to think so hard tomorrow with the unit circle? How could you solve this? How do you get rid of x? Or how do you get to x? Oh, you could use unit circle. I'm just trying to help you guys because you're going to have your calculator tomorrow, right? What do you do to both sides? Do you know? No. You could. Yeah, good. You set each factor equal to 0. And then you solve. You could do sine inverse. That's a little bit of a cheat. You could do a sine inverse of both sides to make sure it seems to work. Now, careful. Sometimes when we do inverse trig in our calculators, which is why I haven't really had you using it, unit circle is so much safer. But sometimes when you do it, it pops you in a wrong quadrant, and you have to kind of think about it. So just a warning. If you know your unit circle, that's the safest bet tomorrow. That's the safest bet. But you could also maybe plug something into sine. Maybe instead of trying to get to this answer, maybe you plug it in and say, oh, hey, his sine is negative 1/2. You could double check that way. Priscilla, go ahead. Because see how it's a ax squared plus bx plus c? It's a quadratic. But it doesn't have an x, it has a sign instead. So you know how with quadratics we factor down using an x method? Now this one, there's no x method, right? They didn't show their work as to how they did it. But they could have, because they could have off to the side, theoretically, taken this and been like, oh, it's a quadratic. A times c is on top. There we go. Does that make sense? And then they could go ahead and say, okay, 1 and 1. No, 2 and 1. Oh dear, I can't even do my x method. 2 and 1. Multiply to b and add to b. If you do the modified x method, you could technically go ahead, come, and then divide everything by the top number. But that's something that we didn't really talk about until later. But you could take that top number, and then all of a sudden you get 1 and 1 and 2 and 1. 2 sine 1 and then 1 minus 1. You actually end up with the numbers that you need. That's a trick. But the other way that we did it before, without the modified x method, with that negative 2 and with that 1, is we would have taken this off to the side and said, okay, there's our 2 sine squared x. We would have used this to split him up. That's what grouping does. The modified x, or the normal x method takes that middle term and breaks him up, and then we do grouping. And we say what's in common, a 2 and a sine. We have 1 sine x. And then we see that this is in common, so that comes out as one of them. And then what's left over is the other one. That's probably the way you're used to. Yeah. Okay. Thanks for stopping me. That was a good timing. Number 20. Number 20, pull out the GCF. It's a difference of squares. Well, actually, they didn't even use difference of squares. They said, hey, wait a minute, he looks like a formula. Is this a T-proof? Oh, it's not? What was number 20? Was it a T-proof? Remember the book shows it differently than we would. Did it say verify or prove?
It says use double angle formula too.
Oh, it was very specific. Okay, it said use the double angle formula. So we couldn't use the double angle formula because there are no 10s and 5s in the double angle of cosine. Hey, let's pause for a second. What are you going to have tomorrow if you read a question on the test that says, like, use the double angle formula? What are you going to have from me? Yeah, so go look and be like, oh, don't know what this is talking about. What's the double angle formula, right? So the nice thing is, like in homework, he might have been like, oh, stink, I don't know what I'm doing. But if, like in the directions Matthew just read, if it said go use a double angle formula, well, double angle formulas, I have cosine of 2u is equal to cosine squared u minus, yeah, nice. Or 2 cosine squared u. Or, right? Oh, is it?
No, it's minus 1.
No, it's mine. Yeah,
It's
mine's
minus
mine.
1.
It's okay, it's okay. Baby pants, baby pants. It's okay, it's okay. Pause. Which of these look like that? There's no 10s, there's no 5s. I know, pull the 5 out. Oh, it looks a lot like this one, right? But the signs are flipped. So they say, oh, ew, I don't like your signs. Pull out a negative. Oh, now you're nice. Done. So it looks like magic. They really just plugged in a formula backwards. Not magic, it's math. Formulas can go backwards or forwards. 22. How? How should you have known to make a triangle? Fraction. Oh, okay, the directions say so. But on the test, how would you know? Right? A trig with a fraction. Go to a triangle. Right? They told us what quadrant. They said in between 90 and 180. Okay, fine. I'll put it in the second quadrant if you tell me to. Label the adjacent and the hypotenuse. Done, done. Label the opposite. It's a 3, 4, 5. If it's not, you could use Pythagorean theorem. Then what? Who comes out when the ratios go in? Trig. There's no more sines and cosines. There should not be. Maybe make a note to yourself. I've been warning you. Kids love to put sines and cosines. I don't know. You hate them and yet you still put them. But let me go ahead and scroll down. Once you have the triangle, you're just plugging in. Get the cursor off of that file on the side. I'm sorry. But then you're just plugging in and simplifying. Plugging in and simplifying. Guys, if this is a long answer, do you want me to show you a trick real quick? If it's a long answer, you could actually box it and say, I'm scared to simplify. If it's a long answer, I don't mind. If it's a multiple choice, what's the dilemma? You have to somehow get it. But you're going to have your calculator, so if the simplifying gets fun, you could always get a decimal and compare to the decimals of multiple choice, especially on this guy. Couldn't you get a decimal, right? By putting it into your calculator and then compare to the other answer choices? So
What if we don't box it and try and solve it and that answer is wrong?
if you try to simplify it and it goes wrong, on a long answer, I'd have to take off a little baby. Does that make sense? But if you stop and you're right, you're not wrong.
For the tangent, we just use our rules and say that
Sine over cosine. Yeah, Matthew noticed that for this one. Now, on the test, I think, Joe, you asked this one the other day. On the test, remember, I'm not going to make you do all this work. That's too much for a long answer, I think. So on a test, you're probably not going to have the sine and cosine to make the tangent. But yeah, Matthew was totally right. Once you had the sine and cosine, you could have just said, hey, u over u. You could have cheated on homework. Not cheated, used your properties, right? But good call. Joe. Can or can't? Yeah, they can show the fraction. That's true. Thank you, Joe. Not all of them go to decimals. That's true. So maybe they would even show you the nice pretty fraction that's waiting for you in the multiple choice answer. So Joe's helping you guys out just a little bit, saying you don't necessarily have to compare decimals. Number 42, you were actually going backwards from a half angle formula. You were going backwards. Hey, ooh, I know, it's silly because you're done memorizing. But remember, the guy who's happy it's cosine would be cosine anyway. Or positive, it's the same. But cosine of u over a. And then they go ahead, and maybe you didn't put the absolute value. Don't worry, that won't mess you up on the test tomorrow. If you're marking that wrong right now with the absolute value, don't worry. The only reason they have to do that is because plus or minus, we don't know where it came from. So that's why the absolute value in some ways needs to be there. But it's okay, that won't mess you up for the test, I promise. Did you guys have, no, you didn't have 62 or 70, right? Ah, sweet. Okay, so let's go back. I know, the crossed out ones are still here because I just lost my picture because I got rid of it. But you guys know which ones you had for homework. Are there any odds or evens that you want me to talk through? Any odds or evens? Cool. 33, 39. 65. Okay, let's go peek at those. Guys, if you're bored and you're like, I'm good, sweet, be working on the review. Remember, we're all supposed to have books out, and if we don't, come grab one. If you're bored, sweet, start working on the review. You don't have to pay attention to us, but just don't talk over me, okay? My voice just can't take it. Salma, what was it, 30? 33. And then 39 for Priscilla. Okay. The directions in 33 are kind of weird because they just tell you sine of 75, and you're like, what's the big deal with 75, right? But the directions make all the difference because they say 75 is not on unit circle, right? 30, 45, 60, 75. But they give us a hint. 75 is half of 150, which is on the unit circle. So I can actually do sine of 75 equals sine of 150 over 2. We're rewriting 75 because this not unit circle, but 150 is on the unit circle. So 150 would be over here, second quadrant. 150 would have a cosine of negative root 3 over 2 and a sine of 1/2. So then I could go ahead and plug into my half angle formula, which 75 is first quadrant, right? So sine is positive. Good, Joe. Thanks for seeing where I was going. And then sine is sad that it's not him. Cosine of u. So positive square root of 1 minus. I would steal the cosine. And then we simplify. But does it make sense I'm using the formula? And I don't know that, but I do know this. So it's okay. Yeah. And then you do same for cosine, same for tangent. Yeah. I saw him. Number 39 also said to use the half angle. The struggle on this one is, Priscilla, it's a triangle problem, right? Because it has the fraction. So then I know I need to make a triangle, but I have to pay super careful attention to where they tell me to draw it. So in my head, I'm basically thinking unit circle and trying to say, okay, 3 pi over 2, that's 1/2, 1 whole, 3.5. They're telling me to draw it somewhere here, so I just make like a random triangle. And then tangent, who is he? SOHCAHTOA. Sine over cosine. Or you could, like if you're going way back to triangle, SOHCAHTOA, you could say opposite over adjacent, like old school. And the reason I'm saying that is because opposite, which you could think sine is y, over adjacent, or you could think cosine is x. Both ways work. Now, if you didn't know, like some people have memorized 5, 12, 13, kind of like 3, 4, 5, because they go together. But you could always do off to the side, okay, I need 12 squared plus, and in your calculator, pretty quickly you would get the third side if you needed to. But then what they're asking for in this one is find, oh, sorry, there's little slashes. Find sine of u over 2, cosine u over 2. Oh, they do talk about what quadrant u over 2 lies. But we kind of talked about something like this yesterday. It's hard to figure that out unless you pick an example. Like 300 degrees is in here somewhere. I don't know where it is, but it's in here somewhere. Half of him is 150. So taking like an example and then dividing it in half, you can kind of tell that when I go to do something like this, I'm going to be looking in the second quadrant for all of my signs. So for instance, sine is going to be a positive because all students, sine's positive in this quadrant, but cosine is going to be a negative. And tangent is also negative because sine over cosine. So when you go to do your signs, although I think, wait, does tangent's formula have a plus or minus? It doesn't, does it? Never mind. And then we go plugging into our formula, which says sine is sad that he's not it. You go looking for cosine, of your triangle. So you would steal the 12 over 13. The nice thing is, technically, in your calculator, you could probably get a decimal fast and match it. Or try to simplify by hand. Does that make sense? So we're going to do the same thing with cosine, same thing with tangent, just taking our ratios, whatever they want, doing the SOHCAHTOA out of the triangle. Cool. And then, Tyler, you wanted 65? Okay. So number 65. Ooh, is a T-proof. Okay. What side did you guys think of starting on? I think my gut reaction would have been the right two, but the problem is I have no idea who that is. I'm kind of like, Right. Right. Joe's telling us 2U because he's pretty much telling us like, hey, maybe we should go look at the double angles. Now the problem is the 2U's, if you look at your formulas because you're stuck, you might start here and try things, but the problem is I don't even know what I'm trying to get that to be. Who are you? Ugh. So if you look at your double angles, the problem is there a cosecant one? No. But what is there that might help us with cosecant? Because who is cosecant? Yeah. So I would have started with making it 1 over sine. Because my brain, cosecant, that's not on my formulas. So I think I would have gone, you could look at your reciprocal identities. Cosecant is 1 over sine. Cosecant of anything is 1 over sine of the same anything. So I can always change this to 1 over sine of steel. Now I can go and say, oh, hey, I have this formula on my sheet. Some of you have it memorized. 1 over 2 sine. Now, look at what you want it to be. I don't mind the fraction bar. That's great. I don't mind the 2. That's great. I don't mind the cosine. That's great because I have a fraction bar, I have a 2, and I have a cosine. But what else do I have that doesn't match right now? But he's in the denominator. Yeah. So look, rewrite it. You can have your 1 over 2 cosine right here. You can have your 1 over sine right here. You can kind of separate multiplication. We can like mix it all around. So what can we make 1 over sine to be? Got it. Do you see how it's helpful to look at where you're going to try to guide you there? And I get it, guys. I would have chosen the right-hand side too, except my brain's like, wait, but who are you? I don't know. Better go play with him. Yeah, as long as you think through who cosecant of 2 theta is. But yeah, Matthew's saying you could have done this side, and he's totally right, because you could have done cosecant of theta over 2 cosine. You probably would have changed cosecant to be 1 over sine. And if you properly, you could use my Uganda trick, or you could divide by, you would end up with 1 over. Maybe that would have been easier. Then you would have maybe realized, oh, hey, that's you. Like maybe you could have gone backwards. That's true. That's not impossible. Like you could have gotten there maybe that way, but both ways work. Is that good? Cool. All right, kiddos. To that end, if you guys don't mind, I'd love to give you some specific hints about the test. Is that cool? All right. Are you allowed to use your calculator? Yes, most definitely yes, right? I have up your test review. Remember, you do not need to write directions or problems, right? We're trying to shortcut, short, sweet, just practicing. Before you leave class today, please make sure you have the number of somebody in the class that you could always reach out to. Doesn't mean that they have to have like all the answers or tutor you for hours tonight, but just to be like, I'm stuck on test review number 59. Do you have anything? Like maybe they don't, but maybe they don't know how to do it either, and they've reached out to 5 other people. Does that make sense? Or maybe they know an honors pre-cal kid that can look in their test review and be like, oh, guys, it's easy. Just do this. Make sure you at least have contact with someone. If not, I know it sucks, but remember chapel kind of? How it was like, even if you're on the end where you're like, I kind of feel alone, you just got to reach out. And someone in this class hopefully is considerate. I think a lot of you are. If someone asked you for your number, to be like, can I ask you, like, can I have your number just in case I get stuck on something tonight? Like, hopefully we would be considerate enough to be like, yeah, pre-cal tests suck. Like, it's nice to have someone to reach out to. Are we okay with that? Making sure you at least have the number of someone? Okay. So maybe before we leave today, maybe you can reach out in your group and be like, do you have someone to reach out to tonight if you get stuck? And they're like, no. Okay, then. We got this? Okay. Test, hints. I'm going to kind of give you guys directions, because don't the directions kind of tell you like which way to go on a problem? Okay. So thinking about section 5.1, before T-proofs, you might have some problems on the test that just say simplify. That just say simplify. Maybe they'll be specific and say multiply, then simplify, or factor, then simplify, or get a common denominator. Hey, isn't that like the 5.1, 5.2 quiz? There's going to be a couple of those. Okay? Maybe long answer, maybe multiple choice, maybe both. We're just talking about multiple choice right now. I'll be specific. So 5.1, 5.2 quiz. There's going to be some like, hey, do this and then simplify. There's going to be some, at least one that says solve the equation. Anybody know what section that came in? 5.3. Good. Solve the equation. And you're going to need the unit circle, or to use something like sine inverse, cosine inverse, tangent inverse on your calculator and make it match, like have a decimal and line it up. But unit circle would be really helpful. You're going to have something, or at least a couple, where you go from a formula backwards. The easiest example that I know we have in the notes I can show you, like going backwards from a formula, it was in section... wasn't this formula backwards? Because it took the hard part of the formula and, oh, it was so nice. So formulas backwards. I'm not saying the specific example, but you might want to either write it down or put a star. This idea of having something that would be so hard to do unless you use the formula backwards. You're going to have to plug into formulas forwards a little bit, in the sense of like, hey, simplify or write this out. I'm going to give you a hint as to what category. It's going to be the sum and difference. Remember the cosine, sine, or sine, cosine, cosine, sine. You're going to have to plug into a couple of those. You're going to have a multiple choice that has to do with plugging into a formula from a triangle. Maybe I give it to you, or maybe I make you make the triangle. How do you know a triangle is necessary? If there's a fraction, good. If it's sine, cosine, tangent equals a fraction, you got to make a triangle. So you're going to have, I'll be honest, you're going to have one that you plug into a big formula with a triangle given to you, and then one where you have to make the triangle yourself. And then, do you guys remember on your 5.1, 5.2 quiz, the number 2 that you made lots of mistakes on, even though it was kind of easy? Can you study that one, please? Okay. Remember I wrote it on the board, and I think it's even still there? Okay, let's study that one. All right, long answer. There's going to be one T-proof. Factoring will be your friend. Vague and yet very specific all at the same time. One T-proof, factoring will be your friend. One, needing a triangle, bless you. And I even tell you, draw a triangle in the directions. Actually, you better draw 2 triangles. Ooh, that's a hint. So one T-proof, factoring will be your friend. Another where you need a triangle, actually 2 triangles. And then the last one will be solving an equation, and it's kind of like maybe something that I told you to highlight in your homework last night. All right, that's a test. Man, I was nice with those hints. So T-proof, factoring will be your friend. A long answer where you need a triangle, actually 2 triangles. And then another long answer where you have to solve an equation, and it might be something like something I told you to highlight from homework last night. All right, cool kids. With that, I'm going to let you guys loose on. You have like a little bit less than 10 minutes to play with your test review. I'm going to walk around if you have any questions. Remember tomorrow, I'm giving you the formulas. You don't have to make a formula page. You're just playing with problems tonight. There are about 15 questions, I think, tomorrow. 9-ish multiple choice. Oh, I guess even less than that. Each question is worth a fair amount, but remember the formulas today were about 1/4 of your test grade. So 3/4 of the test grade are still to come tomorrow. But every problem, I'm going to try to give partial credit, but I really want you guys to try to ace as many as you can where I don't have to take off points. Yeah. Hold on. Who's that guy? Where'd you get him from? Just wrote him down wrong. It's not tangent square. It's cotan square. So that's cotan square. Makes all the difference because tan over. Yeah. Feel free to talk, guys. You can collaborate. You can ask questions. Sorry, you don't have to be silent. I'm just walking around answering stuff. Oh, okay. Then I will, yeah, I think I have time to get copy it, but thanks for letting me know, or I wouldn't have been ready. But yeah, I'll get it ready, Joe. Thanks for letting me know.
In what situations and where it would be like less and high?
If the directions, which I think I said today, if the directions just say solve with nothing extra, like no negative pi to 2 pi or no interval, just says solve, you're going to have to be putting the ends. Mm-hmm. It depends on the problem you have, Matthew. So, for instance, if you have something, I'm going to jump to like the end of the problem and you're needing to answer. So let's say the directions were just solve for all. I don't know why it's so far off. The directions were just solve for all, and you get down to something like tangent of theta is equal to 1. I would look at my unit circle and say tangent is 1 at pi over 4 in the first quadrant, but also 5 pi over 4 in the third quadrant. So then I would say, okay, right, that's pi over 4, but I can get both of them in one shot by doing pi n instead of 2 pi n. Does that make sense? Okay, but what if you have something like sine of 2 theta is equal to 1/2? Good. Sine being 1/2 would be at pi over 6 and 5 pi over 6, right? Now it gets to be a little rough, because then when I do 2 theta is equal to pi over 6, I'm going to have to do plus 2 pi n, because they're not like a nice distance apart. And then I'm going to have to go ahead and divide everything by 2. And that's how you get weird things. Like, oh, hey, it's pi over 12 plus. That, this time, ends up being pi n. But another time, if I had to divide that by, like, let's say it was tangent 2 theta, then it would have been pi over 2n, just by the math. Does that make sense? So still just start off the same way of looking at the picture and trying to condense as much as possible. The time it gets really funny is when there's a 2 or a 3 or a 4 and you're dividing by it later. Does that make sense? Oh, I should have kept going. Sorry, I was just, this is not writing right. I should have also used 5 pi over 6. Yeah, I just didn't finish the problem. Six times 2, so it'd be 5 pi over 12. Yeah. That is not working well. Yeah. What do you got? Mm-hmm. Yeah. Change the 6 to be 3 times 2. So then the 3 stays off. 2 sine cosine becomes sine 2u. So 3 sine 2u, same thing. That makes sense? Guys, really quickly when you're doing the review, because some of you have written out formula pages, and I saw you studying them today. Perfect. Have them out when you're doing the problems, because remember, you're allowed to be looking at formulas. Don't try to be getting them off the top of your head, because you're going to make mistakes, and tomorrow you're not going to be doing that. Another thing that you could think about is if you didn't make a formula page, remember at the end, in all these brown pages before your review, all the formulas are here. So don't make your brain work extra hard on the problems. Go look at those brown pages and find the formula that you need. So either have out your formula page or turn back to the brown pages. But when you're doing problems, look at the formulas. You're allowed to tomorrow. You're allowed to tomorrow. Yeah.
Draw two triangles. What would that be? What do you use two triangles?
What are you looking at right now? Mm-hmm. Good. And why don't you peek in your notes to see if we did an example like those, because I think we did. And maybe it's there and maybe it's not, but I think you can answer your own question. There's 5.4. I see two triangles. So ponder. Because there are two angles. Two angles necessitate two triangles. Yeah. Think about where the parentheses are. Just square him. Don't square root yet. Square first. Let me see what you get. No pluses, no minuses. Yeah. But that's good. Like writing it out showed you that, right? So then rewrite the rest of it. Now, this is the mistake everyone makes. It's illegal to square root yet. But you can pull out the 25. Got it. All right, if you guys borrowed a book, feel free to put it back. I'll be here during lunch. I'll be here during period 7 after school. Sam, I'll be here next for 5th period if you need me. Drop by if you want to ask a question or if you want me to give you a sample problem. You just have to be specific as to, can you give me a triangle problem? Can you give me a T-proof? Sure. I'll give you a whiteboard and we'll see how you do. Feel free to come in. You're welcome. See you guys later.